A uniform rod of length L is pivoted at one end. Okay, let's draw the picture first. There is an uniform rod and it is pivoted at one end. There is a pivot, that means fixed here, and the length is given, and the length of the rod is L, and released from horizontal position. So what will be the physics here? That if you release from here, then there will be a motion, that is a rotational motion. The rod will rotate with this axis because it is fixed. Now find the angular velocity when it reaches the lowest position. So the rod will reach this one. Okay, so the rod will be here now. So we have to find the angular velocity. So where the angular velocity comes from? There is a rotation, so there is an angular velocity. Okay, that's the problem, that we have to find the omega. Now the fact is that when the body is here, there is a potential energy. There is no kinetic energy, no type of kinetic energy, no rotation when it is fixed here. When it is fixed here, there will be no kinetic energy, no rotation, no translation. There will be no translation because it is fixed here. So there is a potential energy. So let's write down the potential energy first. The potential energy at fixed point, we say this fixed point F, fixed point. So F fixed is, what is the potential energy? You can easily write that this is nothing but M, V and H. Okay, there is something different. What will be the H? Don't calculate this H, not the H. So the idea of potential energy is lying there. There is a center of gravity, and this is working here, not the whole body. Because we can treat that the whole mass is concentrated in that G. The distance between the fixed point and the G is nothing but L by 2. And when the body moves, look carefully, when the body moves, there is a change, and who is changing? This G comes here. Okay, this G comes here. So this is the change. This is the height L by 2, and this is nothing but H. Okay, H is not L but L by 2, because we have to calculate the point where gravity acts, that is center of gravity. Clear? So this is mg L by 2. This is the change in potential energy practically. If you take that this is 0, then there is a change, and this is mg L by 2. Very important and very crucial matter. So the potential energy that changes, which turns into the rotational kinetic energy. So this potential energy turns to a kinetic energy, that is rotational, and it is half I omega and square. Clear? So this is half I omega square. So the equation gives us half I omega square equals to mg into L by 2. This is not L. This is not L but L by 2 because of the position of center of gravity. Now there comes omega square equals to mg by I. Okay, but this I can be calculated because this is a uniform rod. So I for uniform rod is 1 by 3 and m and the length and square. This is different thing than the G. You can take the L by 2 here because the length of the rod is L, and the length of the rod depends, and moment of inertia depends on L, because we are fixing at this point. If we fix a point here, there will be some different result. Okay, so I is 1 by 3 ml square, and we are giving mg by 1 by 3 and ml square, and there is another L. Sorry, there is an L. So clearly we can calculate it, we can simplify it by some algebra 3g by L. Oh, and another L is missing. So omega square is 3g by L, or omega equals to by L, and there is a root. So this is our answer.